Hello, welcome to part 3 of Exponents, and here we're going to discuss the power rule amongst a few other smaller rules. So the power rule 3a, if we have the same base, we multiply the exponents. For example, we have a r s, so that means we have r times s because we brought this to the power, and then here our base is the same. So for example, if we have 3 squared and then we cube it, so we have 3 squared times 3 squared times 3 squared, which is what cubing means. That means, as before, we learned if we multiply, we add them up, so it's 2 plus 2 plus 2, which is 3 times 2, which is 3 times 6, 3 to the 6th, so which is the same thing as 2 times 3. Now here, using the variable x, we go through the same process, and we see that we get x to the 6th, just as we would if we expanded it out and added it. So, when you take a power to a power, you multiply the exponents. Another aspect of the power rule is if we have anything inside the bracket. So here, when we have the power outside of the bracket, we have to bring the power inside everything that's inside the bracket. In this case, we have inside the bracket x and y, so that means we have x to the n, y to the n. And showing an example of how this works, so if we have 4 times 3 squared, well, that's the same thing as 4 times 3 times 4 times 3. I just remove the brackets and rearrange it and put the 4's together and the 3's together, and that's the same thing as 4 squared times 3 squared, and then I worked it out in detail. 4 squared is 16, 3 squared is 9, and that's how I got 144. Now, if I do that with variables, it's the same idea. So instead of numbers, I used x and y squared. I bracketed them x times y times x times y, and then I rearranged the x's, I rearranged the y's, and that was the same thing as x squared, y squared. So when you take a power of a product, you apply the exponents to all of the factors of the product. And in C, when we have the power rule to the quotient, it's the same idea. We want to apply the exponent to all the parts of the quotient. So that means if we have a over b inside a bracket, remember this is inside the bracket, and we have the r out here, we bring the r here and here. Here is why it's true, so this is just an abstract version, r factors, and a over r, b over r. So when you take a power of a quotient, you apply the exponents to all the parts of the quotient, not just one, not just the top, not just the bottom, but all the parts. And you want to make sure that the bracket is covering the whole thing. So it's whatever inside the bracket is what that exponent is affecting, or that power is affecting. Now let's look at some examples. In example number 22, we have x to the 9th power. That whole thing, everything inside the brackets, is to the 4th power. So we use our power rule. We multiply 9 times 4, and we keep the x, and that's how we get x to the 36. In example number 23, we have a to the 4th, b to the 3rd, and this entire thing, and that's what the bracket is telling you, that entire thing is being brought to the 5th power. That means the 5 will be multiplied by the 4 from the a, and the 5 will be multiplied by the 3 from the b. The power rule tells us that it's a to the 4 times 5, b to the 3 times 5, and that's how we get a to the 20th, b to the 15th. In example number 24, as you see, this is a little bit more complicated. So what I'm going to do is I'm going to go to the whiteboard and work this out in detail to give you an idea and show you one way that you can approach this problem. So in number 24, we have a cubed b over c to the sixth to 3. So we see that all of these bases are different. So the only thing we really have to do here is apply the product rule. And that means we're going to take this cubed and we're going to multiply it by everything that's inside there, like this. So we have a 3 times 3. B, well, since b is to the first power, it's going to be b times 3. And then finally, C, 6 times 3. So you have to do it to everything that's inside the bracket. So this power is affecting all of these. So now I'll continue. A to the 3 times 3, well, that's going to be a to the 9th. B, 1 times 3 is 3. And finally, 6 times 3 will give me C to the 18th. And that's my final answer for this one. In reviewing 24, based on what we did on the whiteboard, here we have, as you see, I brought this 3 inside the brackets into everything, both the A, B, and the C, because all of those are inside the bracket that is brought to the third power. And then I did what I usually do. Here I have 3 times 3 is 9. 1 times 3 is 3, 6 times 3 is 18, and there's nothing else I can do, so I'm finished simplifying that particular example. In example number 25, we have now something with a negative coefficient, and it's inside the bracket. So let's go to the whiteboard and see how I would work this particular example out. In number 25, we have negative 2, x to the third, z to the 7th, and cubed. So again, we're going to just we only really need to apply the power rule to this. So I'll do my numbers first. Negative 2 to the third. And then I have my x, and I multiply 3 times 3, and my y, z, 7 times 3. So here I have negative 2 to the third, so that means negative 2 times negative 2 times negative 2. So that means here we have negative 2 times negative 2 will give me positive 4, and then positive 4 times negative 2 will give me negative 8. Now for my x term, well, I have 3 times 3, so that means I will get x to the 9th. And then my final z term, or z part, I'll have 7 times 3, and 7 times 3 will give me 21. And this will be my final answer. In reviewing what we just did on the whiteboard in example number 25, so here I have the negative 2 to the third power. Then I did the x's, the z's, all of these to the third power. And then I worked each one of these out. Remember, negative 2 times negative 2 is positive 4, and then positive 4 times negative 2 will give us the negative 8. And then, of course, the x is 3 times 3 is 9, and the z is 7 times 3, which is 21. In example number 26, here we have something a bit more complicated, so I'm going to work this out on the whiteboard for you. In example number 26, we have 2q to the 0 power, s to the 4th power, over 5q to the 9th power, s. And all this entire thing, everything that's inside there, is raised to the 4th power. So what I'm going to do is what I usually do, is I'm going to put my constants or my numbers, my variable, my q's, and my s's in different brackets and bring them all to the 4th power. So I start out with my 2 over 5, and I'll put that to the 4th power. And then I have my q0 and my q to the 9th, and I'll put that to the 4th power. And then I'll put my s to the 4th and s, and I'll put that to the 4th power. So I'll work out each one again separately. So I will use my power rules to do this. So I have 2 to the 4th over 5 to the 4th. And then I have, for my q's, I have q 0 times 4 over q 9 times 4. And then I do the same thing for my s's, s times 4, 4 times 4 over s to the 1 times 4. And now I work it through. So I have 2 to the 4, that gives me 16. And on the bottom, I worked out 5 to the 4th power. It turns out that that's 625. And then, well, q to the 0, well, that's 0 times 4 is 0. And remember what I said, that anything to the 0 power is equal to 1. So that's just going to be 1 over q to the 36. And then for my last part, I have my s's, and I have my s, 4 times 4 is 16, and then s, 1 times 4 is 4, s to the 4th. And then I worked it out, further work it out, so I have my 16 over my 625, and then I have my 1 over q to the 36, and here I have 16 s to the 16, s to the 4, so that's going to be s to the 16 minus 4. So finally I'll get, in the end, I'll get 16 over 625 times 1 over q to the 36, and then times s to the 12th, and then I can rewrite it all together.
16s to the 12th all over 625 q to the 36, and then I am done.
In reviewing what we just did on the whiteboard in number 26, so here I put everything. I brought the power out that's outside here and brought it inside and took everything to that power by multiplication. Now remember, 0 times 4 is 0. And remember what anything to the 0 power is. So when I just worked all this out, 5 to the 4th power, etc., and this was my final answer. So then there are some other properties of exponents, and these are things that you really should know when you're working out problems or examples that are a little bit more complicated because this stuff comes up. So remember, any single number or variable is always to the first power, meaning that if we have just x all by itself, that assumes that's to the first power. So for example, 3 is really 3 to the first power, or a is really a to the first power. And in the case of 2x, well, 2 is to the first power, x is to the first power, and that means we can look at it as 2x bracket 1 to the first power, where everything is brought to the first power. Anything to the 0 power is equal to 1, no matter what. For example, when we had situations, here x over n divided by x over n is n minus n is equal to 0. That gives us x to the 0 power. However you get there, anything to the 0 power is equal to 1. Thank you very much. I hope that you enjoyed this video and that you learned a little bit more about exponents. Stay well and take care. Bye.